Alright, hey and welcome to example 1 in the Pyro chapter. So in this chapter we're going to take a look at how to use the Pyro solver, how to create smoke and fire and explosions and everything in between that, and how to actually solve volumes and how to source volumes and what velocities are and what velocities are and kind of stuff like that. So in this first example here, example 1, we're just going to go over a quick and simple way to source a single frame of a volume. We're gonna source a volume of a sphere here. So first of all, we're gonna create a sphere, just normal sphere. Make a volume out of that with an ISO offset, like this, fog volume, and call it density. Put uniform sampling divisions to 30 to get some sort of a lot of voxels. We now have 27,000 voxels. We wanna solve those in the Pyro solver. So to bring them into our .NET, we're going to put a null here so we can easily recognize them, called out density. And this is a null we want to reference later on in our .NET. We're now going to drop down a .NET and call it example 1 Pyro dop. So in the .NET, we can do particles, we can do RBDs, we can do anything like this, but in this example, we're going to do it with Pyro. So if we dive into this .NET, this is a different context, right? It's called dop. We kind of went over that with particles, but it's the same here. So the .NET has a whole wide other range of nodes that refers to making things in a dynamic state. The two most important nodes for Pyro solving is a smoke object and the actual Pyro solver. The smoke object in this example we will use to source our volume, to actually bring it in. And the Pyro solver is what's gonna actually solve it and apply the velocities and do all the magic, basically. You can dive into the Pyro solver. You can see there's a lot of things going on if you want to unlock it, like advection, velocity update, and sourcing and stuff like this. These are all built with microsolvers or gas nodes, but we're not gonna talk about them too much right now. We're gonna look at them in later examples, but for now, let's dive up and have a look. So I said that this with a smoke object, we're gonna actually source the volume. So let's go to the smoke object. There's a lot of things going on here. We're gonna go over the smoke object a little bit more in depth in a later example, but for now, we're just gonna drop it down and go to the initial data tab. In an initial data tab, we actually wanna reference our volume here. So in the density sub path, we're gonna bring in our density, which is object intro to Pyro and out density, as we defined before. This means that we actually do get our volume in here. We can multiply it by the scale on the side, but I want to keep it the same, so I'm going to put it to 1. We have a couple of other options here. We can bring in velocities, and we can set a wind tunnel direction, but I'm going to keep it the same as it is now, just to make it easier. And then we're going to drop down the Pyro solver. As I said, this is where all the magic happens. This is where all the velocities and the volumes are actually solved into a dynamic context. The Pyro solver is a very complex node. It has a lot of things on it. For this tutorial, we're not going to do too much. We're just going to go to the shape tab, and we're going to tick on turbulence and tick off dissipation. So turbulence is basically adding a turbulent velocity to our simulation. So I just did that to kind of see a little bit more what happens when we actually are solving this dynamically. So if we would go ahead and play it, it will look like this. And that's kind of like it looks very much like smoke. I don't know what type of smoke, but it looks smoky to me, you know, so that's really cool. So that's the beginning. That's how you source a volume and how you kind of just displace it or add some velocities to it. Cool. Yeah, so that's all for example 1. See you guys in example 2. Bye.